Good morning, ladies and gentlemen. Welcome to the Good Burger, home of the Good Burger. May I take your order? Today we're going to be talking about converting customary and metric units, and we've lumped them together because it's the same skill just applied to different measurement systems. And essentially what we're going to do is we're going to use ratios to convert between them. So this is just another way to solve problems like this. So a couple of quick thoughts here to highlight in our notes. The first one is this idea of a conversion factor. And a conversion factor is a rate that compares equivalent measures. And so I'm going to rewrite some of these as a fraction, right? But so it's 60 minutes, right, is 1 hour. And you could have written this, right, this is also equivalent to 1 hour is 60 minutes, right? You could have written those either way depending on what you need. But both of those units of measure, even though having different units, are worth the same amount of time. All right? And so to convert customary units, that's where we're going to start. You can either use this conversion factor or you can use equivalent rates. So we'll show you a couple ways to solve these problems. All right? So customary units of length. A sidewalk is 4.5 feet wide. However, regulations state sidewalks be no wider than 66 inches. Does this sidewalk meet the regulations? So the conversion factor here, right, is essentially that we are going to take 4.5 feet and we are going to multiply it by the rate of 12 inches to 1 foot. And basically what ends up happening here is, right, these feet cancel out. Right? These feet cancel out, and so what you end up doing is you end up taking your 4.5 feet, and for every one of those feet, you're timesing it by 12 inches, and then you would end up with the answer. Right? Similarly, if we were to use an equivalent rate, right, and we would set this up, we would use, again, the same conversion factor, 12 inches is to 1 foot, except now, how did I get from 1 foot to 4.5 feet? Well, I multiplied by 4.5. So in my numerator, I must also multiply by 4.5. Notice that regardless of which one of these we're solving, we end up doing the same math. The setup just looks different. So why don't you pause the screen and see if you can get the answer. I showed my computation here in the center, but that is 54 inches. Right? Maybe you did that in your head. 4 feet times 12 inches is 48 inches. Half of 12 inches for that half a foot is another 6. Right? If we're talking about capacity here, we've got 15 gallons of water for a camping trip. Right? I want to know how many quarts of water that is. So I'm going to walk you through the two setups, and then we'll pause again and solve. Right? Notice again, using the conversion factor, I know that 4 quarts is a gallon. It is important to set the conversion factor up in this way because then when I'm doing this, the gallons cancel themselves out, right? Because essentially what ends up happening here, right, is you would end up with, when you multiply, you would end up with gallon times quarts over gallons, and so the gallons would just cancel themselves out, right? Gallons over gallons would just equal 1. And so we end up with 15 times 4 quarts, right? 4 quarts in every one of those gallons. The equivalent rate here, same idea. Same idea. How did I get from 1 gallon to 15 gallons? Right? I'm timesing by 15. How did I get from 4 quarts to however many quarts? I'm going to have to times by 15. I said I was going to pause this one, but hopefully everybody's doing this in their head. How many quarts are we looking at? Right? That's 60 quarts. That is 60 quarts. After these first couple, if this isn't making sense to you, I would highly recommend you pause the video and you come and see me. Okay? So here we are converting weight. We have alpine pika as a small mammal in the rabbit family. I recommend Googling the alpine pika if you're interested in looking at a cute little animal. They weigh approximately 10 ounces. How much does that weigh in pounds? Okay. And so this is a little bit different in that right? How we're getting there is that we are canceling out ounces. This looks like a weird word, right? We probably should have just written OZ. Anyway, the ounces cancel out, so I end up with 10 over 16, and I want to know, right, how many pounds that is. Right? And so here I'm asking you to convert this down into a decimal. And so this would simplify. 10 over 16 would simplify to 5 over 8. Right? And maybe you know what 5/8 is as a decimal. Regardless here, we're going to be doing some division. So why don't you pause the screen and see if you can't figure that out. This is going to be an awfully kind of deep decimal problem. Give ourselves some space here, right? Because I have 0 and 0. And so how many 16s are in 100? I believe that is 6. And that is 96. And then I've got 4. Probably need to get rid of some of this work. I didn't plan ahead. This is what happens when you make videos in the morning when there are no students coming to school. All right, and then it's 2. And I have a leftover of 8. And then it'd be 5. And that would be 80. And so how many pounds is that? That is less than a full pound. And so I have the equivalent rate here. And this one's really tricky because we're actually kind of, how did I get from 10 to 16 ounces, right? Because this is going to be a decimal, this one's going to be very tricky to kind of compute. Excuse me. We're actually going to be dividing this way to get, how did we, oops, excuse me, I wrote the arrow backwards, right? To kind of get between these two, the conversion here is really, really weird. We end up dividing kind of the same idea here to kind of get this conversion between the two, right? And here we still end up with that it is less than a pound. And I think that's the key here on this particular problem, is starting to use a little bit of reasoning here. If you know that my ounces is getting smaller, does it make sense for my pounds to get bigger? Switching to metric. Switching to metric. In the past, you might have used King Henry died by drinking chocolate milk. We might have done some conversions using our powers of 10. You're still welcome to use those, but I am going to show you how to use some equivalent rates and conversion factors here today. Right? So while building a skate ramp, they cut a board 1 2/10 meters long. How many centimeters is that? So the conversion factor here is that 100 centimeters is a meter. Right? So when I multiply these things together, my meters cancel out. So for every one of my meters, I know that that's going to be 100 centimeters. Right? Times it by 100, that would be 120 centimeters. Okay. Right, how did I get from 1 meter to 1 2/10 meters? Well, that is times 1.2. So here we go, times 1.2, still 120. Again, if this is not making sense to you, stop, let me know, ask some questions. Let's do a couple problems together. Right? An aquarium holds 2 2/10 hectoliters of water. If Raji poured 150 liters in already, how much more water does he need? And so here we have to convert from liters to hectoliters and then do a little bit of subtraction. So here we are, conversion factor, 1 hectoliter, 100 liters. Okay. So when I multiply this out, my liters cancel. 150 times 1, 150 over my 100 liters. Right, so that is 1 5/10 liters. 150 divided by 100. And so the difference here is 7/10 hectoliters. And I got that when I subtracted there. Right? How did I get from 100 to 150? right? That here is times 1.5 actually. Maybe you had to do 150 divided by 100 to figure out what this multiplication piece was. That's fine. That works, right? So you're going to multiply by 1.5 up top as well. One more. I appreciate you sticking with me. All right. Lyle has a bowl that contains 8/10 kilograms of salt. He uses a spoon to remove 850 centigrams. How much salt in centigrams remains? So here we go. Using equivalent rates. How did I get from 1 kilogram back to 8/10 of a kilogram? So the way I solved this one, right, to figure out what's going on here, I know that I'm getting smaller, so I know I'm going to be dividing. What I actually did was use a fact family here, and I actually divided by what I had. And so if I'm dividing here, now I'm dividing 10 by 8. That's 1. Whew. All right, here we go. I'm dividing by 1 and 25/100ths, and so up here we're going to do the same thing. Right, the whole idea here is figuring out how did I get from what I started with to what I need to end up with. So why don't you pause the screen and see if you can solve the rest of the problem. To do the math that we have written here, when I divided 100,000 by 1 and 25/100ths, I got 80,000. And then how much salt remains was the question being asked. So I have 100,000 minus 80,000 left me with 20,000 centigrams. 2 practice buddies to complete here, 5-8 and 5-9. You must complete them both. Come and see me with questions, but have a great day.